Okay, in part B of the same example, we now know the value of k. We've shown that k is a quarter times the natural log of 3. K is the constant. It will never change. It will always have the same value for every calculation you do using this equation. So once k has been worked out, write down the original equation again, but replace k with what it is. Not only that, but put brackets around k once you've worked it out. Whatever it is, make sure brackets go around it. So the power of e is now negative, and then brackets, a quarter natural log of 3, and then outside the brackets you've got t. It is crucial to put k in brackets. It makes life so much easier. Now, part B says, how many days does it take for the mass of the leaf to reduce by 60%? To reduce by 60%. So what that means is that there's only 40% remaining. So 40% of the initial mass of the leaf. So reduce by 60% means there's 40% of the original mass remaining. So 40% is obviously 2/5, 40 over 100, cancel it down. So 2/5 of the original mass remains. So the original mass was m0, so 2/5 of m0 is remaining. And we want to work out what t is when the mass takes that value. So what we're going to do is we're going to sub in m equals 2/5 m0. So we're going to replace m with 2/5 m0 and work out what t is. So chuck it in. We're going to have 2/5 m0, and that's equal to m0 upon e to the minus, and then what our value of k is, and then that's being multiplied by t. Now our job is to work out t. So again, I'm going to divide through by m0 to get rid of it. We don't care what it is at this stage, we want to work out t. So we're going to get 2/5 is equal to e to the minus, and then we've got a quarter natural log of 3, and that's being multiplied by t. Now, we have an index equation. It's an index equation because you've got an indice here, and the power is unknown. Remember, t is part of the power of e, so the power is unknown, it's an index equation. So what we're going to do now is we are going to take natural log of both sides. So we're going to be left with natural log of 2/5. And that's equal to, now, what I have here is natural log of e, and then we have our power. I'm going to make this power the coefficient of the log using log rule 3. So that's going to give us minus, and then we're going to have a quarter natural log of 3 multiplied by t, and then we've got natural log of e straight after it. Now, we're taking the natural log of e, just like we talked about in example 1 and before. This just gives you 1. I'm taking log to the base e of e ends up giving you 1. So we're going to be left with natural log of 2/5, and that's just equal to minus a quarter natural log of 3 multiplied by t. So the plan now is to work out t. So what we're going to do is we're going to divide both sides by the coefficient of t by the negative, or you could rearrange both sides and divide by a positive. It doesn't matter. Remember, this is an index equation, not an inequality, so dividing by a negative or positive doesn't matter here. So natural log 2/5 all divided by the negative of 1/4 natural log of 3, and that's just going to give us the time t. So all we need to do now is just type the expression that we have in here on the left hand side into our calculator, and then we'll round it to 3SF. Okay, it equals, and that's going to give us about 3.3361. And the reason the answer is positive, and it has to be positive because time is positive in all these questions, so you can't have a negative. The reason it's positive is because the top line's negative. Remember, you take the log of any number between 0 and 1, that's going to be negative. So top line's negative, and then the bottom line is negative here because of this negative. So negative divided by negative, that's why we get a positive. So our answer here is t equals 3.34, and it's days. Time is measured in days in this question, and that's the 3SF. So that is the time when the original mass of the leaf has reduced by 60%. In other words, there's only 40% of it remaining.